Hey there, I'm Ari from the Tech Buyers Guru, and I've got something really exciting for all you folks out there interested in PC cooling. It's the brand new T3120 fan being released today, August 12th, 2021, by Phanteks. Now, of course, Phanteks is no stranger to cooling. Fan is in the name, despite the funky way they spell it. But they haven't done a lot in the fan or cooling market recently. They've been focusing most of their attention on cases, and they have a huge line of high airflow cases, really beating the competition from everything from the P200 up to the P500. They have great products in the case market, and they've leveraged that experience to create this brand new fan. They said, we know PC cooling. We know how air moves inside of a chassis, and that's what makes this fan different. It's based on optimizing for the PC environment. So it turns out that they actually came to me a month ago, exactly, July 12th, 2021. They said, we want you to do a launch day review of our fan. I said, I just completed a two-part series. Actually, that day, July 12th, 2021, I released the second in my two-part series looking at the best radiator and heatsink fans. I named the Noctua NF812X25 the best overall cooler fan, and the runners-up were the Thermaltake ToughFan 12 and the Arctic P12 ARGB. And frankly, I said, look, I'm sorry you missed my shootout. They said, hey, look at our marketing materials and let us know if you'd like to do a launch day review. I said, okay, I'll take a look. And I looked and I said, whoa, this is a little bit different. Okay, this is not just another clone of the Nidec Servo Gentle Typhoon. This is really interesting. Why don't you send me a few samples and I'll see if I can get a launch day review set up for you. I still have my rig set up with my 240 millimeter rad that I used for that shootout. I'll just do those benchmarks. I can't test all of your claims, Phanteks. They said best case fan, best heatsink fan, best radiator fan, best at everything ever in history. Okay, well, some of those claims cannot be tested today, but I will be showing you benchmarks on a 240 millimeter rad, the Corsair H100i, which of course is well known to probably everyone out there. But before I get into the benchmarks, I want to talk about why this design is truly different from every other fan that's come before it. So, T3120. The 120 is probably pretty obvious, but what about the T30? Well, 30 stands for the thickness. This is a 30 millimeter thick fan. Now that is going to cause some problems in some scenarios. For instance, if you have a large radiator where you have very little clearance, particularly at the top of a chassis, the extra 5 millimeters could cause you a lot of trouble with interfering with your motherboard, VRM coolers, or your RAM. You may also have a heatsink that's designed to be offset just enough to clear that first RAM slot. And if you add a 5 millimeter thicker fan to the front of it, now you're going to block that first RAM slot. So I want to get that out of the way right from the start. 30 millimeters could cause you clearance issues. So measure your application before you jump and buy this fan after seeing the benchmarks. It is thicker. But Phanteks says that brings some advantages, like a larger motor, deeper blades, and really a stiffer frame. So they're able to optimize for all that. Now, that borrows from some competitors. I know Silverstone, for instance, had some 38 millimeter thick fans back in the day, but they didn't excel at everything. In particular, they may have been a little bit louder than some users wanted. So what else has Phanteks done to make this thicker fan better at everything else? Well, let's talk about the bearings. It uses magnetic levitation bearings. Now, you may know that Corsair, of course, made that famous with their ML line of fans, but they didn't invent magnetic levitation bearings. So Phanteks hasn't stolen this from Corsair. They're just applying it because it's a non-contact design. So the fan levitates when voltage is applied, and that means you don't have any rubbing of the bearings. That's a particular problem with ball bearings. It's also somewhat of a problem with hydraulic bearings, but with this you have that non-contact solution. So you should eliminate the bearing noise. Now, third, the fan blade design. Now, this uses a design that's reminiscent of Noctua's NF812X25, which is kind of based on the Nidec Servo Gentle Typhoon. It's also reminiscent of the thicker blades on the Arctic P12 series. But this is 7 instead of 5 on Arctic and 9 on Noctua and the Gentle Typhoon. So it's kind of splitting the difference, still giving you a thick, heavily swept design, but optimizing. Again, Phanteks, I'm sure, tried a lot of different fan blade designs. So this has 7 heavily swept fan blades. But another thing they did, the fourth innovation they did, was the materials. Liquid crystal polymer. Now this is used on the Noctua NF812X25, but no, Noctua did not invent it. It's used famously in Kevlar, bulletproof vests. It's a very resilient material. It's very different from the plastics used in most fans and frankly throughout the PC industry. So what you're going to see is they don't have a way of making this look like a single color because of the material. It's not easy to, just make it all black. Look, Noctua released its brown version years ago and still hasn't released the black version. And it's no doubt because it's really hard to dye this material. So you're going to see the marbling, the kind of the inconsistent but interesting coloring of both the blades and the frame. That's because of the liquid crystal polymer that is used to stiffen the fan blades and the frame. And I have mentioned on my channel before that Arctic had a really innovative design with its P12 blades, but really being heavily swept and very long, they have a problem with resonance. Basically, that material, that plastic, vibrates at certain RPMs. I'm sure Phanteks was aware of that when they did their engineering analysis, and that's why they chose not only a slightly smaller blade, more of them, but also this liquid crystal polymer to really stiffen those blades so that at high RPMs, they would not shake. Now, there's another really cool innovation here. So they actually have a switch built right into the hub that allows you to choose between 3 modes of operation, regardless of the software you're using to control your fans. This is a 4-pin PWM fan, so you can control it with software. But this mode selector switch allows you to choose between hybrid mode, which maxes out at 1200 RPM and also drops to 0 when the PWM signal goes below a certain threshold. And that's actually at the 500 RPM mark. So it goes from 0 and then jumps up to 500 RPM, maxing out at 1200 RPM. This is really good for a case fan environment where you don't want any noise from that at low levels, low thermal threshold. And then you want it to kind of jump up starting at 500 RPM, which is actually probably a pretty good level for basic case cooling. Then you also have a performance mode that maxes out at 2000 RPM. It's not hybrid, so it doesn't go down to 0. I don't know exactly what it's going to be. I'll show you in my benchmarks, but the minimum RPM will not be 0. But that's going to be very comparable to a lot of other fans out there that max out around 2000 RPM. That's become pretty typical. I find that it's almost always a little bit loud, but we'll see in the benchmarks. I'll do some decibel normalization, so we'll see how it works out, not just at max, but below max. And then there is also what they're calling their advanced mode. It's basically industrial style, 3000 RPM. Most people are not going to want to use that, but it will kind of draw the attention of all of you folks out there who've been buying Noctua industrial fans for years. I'm not a big fan of those fans because they're way too loud. Okay, yeah, they blow a lot of air, but that's not what makes for a really good fan. I don't recommend them, but I know a lot of folks like them. Well, if you want something like that, Phanteks will give it to you. Max it out at 3000 RPM with that selector switch. So before I get into the benchmarks, let me talk about the pricing. This is definitely a premium product coming out in a 1-pack at $30 or a 3-pack for $85. So you save $5 with the 3-pack. That's not a killer value, but this is really not about affordability. It's about premium performance. And yes, you're paying a premium price, but if you've got a 360 millimeter rad or you want to equip the whole front panel of a case with 3 fans, the 3-pack makes a ton of sense. Otherwise, the 1-pack is the one you're going to want to go with for other applications. For instance, a 240 millimeter rad like what I'll be testing on today. So a whole ton of innovation went into this fan, and that is why soon after completing a really extensive shootout of cooling fans, I decided to take up their offer and run some benchmarks on this fan. So without further ado, let's jump into them now. But before we get to the charts, let me talk about the test setup. First of all, there's a really convenient PWM splitter built into these fans, so you could connect one to the other and then connect that second fan directly to your CPU fan header, making the cabling really neat. Note that to mount these fans to my Corsair radiator, I had to use the screws included with the Phanteks fans because, of course, these are 30 millimeter thick fans. This does introduce a potential incompatibility, and indeed one of the 8 screws did cross-thread a little bit into my Corsair radiator. While Phanteks has clearly paid a lot of attention to the design of these fans, it does allow a bit of a gap to form between the fan and the radiator because the rubber dampers at the corners are non-removable. Now here are the fans installed in my test system, up and running. I think they look really good. Underneath the cooling block is a Ryzen 9 3900X locked at 4.2 gigahertz. Now, as always, I start with maximum RPM tests, not because I think it's the best way to compare fans, but because people are interested in this. Now, keeping in mind that the T30 actually has 3 different modes capped at 1200, 2000, and 3000 RPM, I actually just went with the advanced mode, capped at 3000 RPM, and then adjusted it downwards for my other tests using the Argus Monitor software suite. So here we see it maxed out 3000 RPM, and it is just going bonkers. It is so far ahead of the other fans and also much louder than even the ultra loud ML120 from Corsair. So later in this video, I will be providing samples of the audio of this fan at various RPMs, including 3000 RPM, and you'll see that you probably don't want to use this setting, but hey, it's there, and for bragging rights, wow. It's pretty amazing. All you guys who are using those industrial fans from Noctua, eat your heart out because this will kill those fans. Look at how much better it is than even the Noctua NF812X25, and that 2500 RPM fan from Corsair doesn't stand a chance. But it's really loud. So let's move into those decibel normalized tests. Truth be told, I didn't know quite what to make of those results at 3000 RPM because I've never tested a fan that runs that fast. But here at a normalized 35 decibels, whoa, things are looking really good for the Phanteks T30. It's by far the most effective cooling fan in this chart, and that includes versus the Noctua NF812X25, which just a month ago I named the best cooling fan ever for radiators. So we're talking about a 3-degree difference. If you look at all the other contenders on this chart, there's only a 2-degree difference between them all. And the Phanteks is 3 degrees ahead of the best. So this is a very, very big, a very significant delta. You don't typically find this type of advantage in a fan design, even a new fan design. So there's something truly revolutionary about the T30-120. Let's look at some more results. All right, at 40 decibels normalized from 2 feet, again, a huge advantage for the Phanteks T30, 68 degrees. It's beating the Noctua by 3 degrees again. So it was not a fluke, and it is way, way ahead of all of the competition. Keeping in mind, Noctua is the best. So look, against really good fans like the Arctic P12, it's a 5-degree difference. That is not a bad fan, folks. The P12 is an excellent cooling fan. To be 5 degrees ahead of that, it's almost as if Phanteks has unleashed some black magic. Let's look at the next chart. So at this point, most of the contenders have dropped off the chart because they simply don't spin fast enough to reach 45 decibels at 2 feet. But the Corsair ML120 and Scythe Wonder Snail 120 are still in the mix because they do have relatively high maximum RPMs. And at this point, it's perhaps no surprise that the T30 still has a 3-degree advantage over its nearest competitor. Now, I do believe that the advantage here is slipping away a little bit, and we get diminishing returns above around 2000 RPM. I personally wouldn't run fans like this. I think they're a little bit too loud. But if all you care about is performance, Phanteks has you covered either way. It's the best when decibel normalized. It's the best at maximum RPM. It simply cannot be beaten. I have one more chart that will really blow your mind. Let's take a look. Okay, so here I've listed the Phanteks twice. First at its maximum RPM, and then at the minimum RPM I tested, which was at 35 decibels normalized. Look at these results. The Phanteks T30 at 35 decibels is better than nearly every fan on this chart at maximum RPM. The only fans that beat it are the Corsair ML120 and the Scythe Wonder Snail 120, which are ridiculously loud. So this just goes to show how dominating this new design is from Phanteks. The T30 is unlike anything that's come before it. For the Phanteks T30 at 35 decibels to tie the Noctua at maximum RPM, 40 decibels, we're talking total domination. Now, of course, the tone of the fans is also important, and that's why I'm going to be sharing with you some audio samples. As promised, I have 35 decibels, 40 decibels, and maximum RPM. And as a reference, I will be including clips from the Noctua NF812X25 at 35 and 40 decibels. All right, I included that 3000 RPM audio sample basically to convince you not to use it, but hey, it's there if you want it. And overall, Fantex has definitely checked all the boxes with the new T3120. It's a simply superior fan to everything that's come before it. I can vouch for Fantex's claim that this is the best radiator fan ever released. Now, they also claim it's the best heatsink fan and the best case fan. Now, those of you who have seen my previous videos know that typically the best radiator fans are not the best case fans, so I can't vouch for that before testing it. Maybe I will do that in the future, but for now, I'm just recommending it for radiators. It is simply unbelievable. Now, let me share a couple of tips and some observations as well. First of all, in terms of setting this up, I actually spent about an hour scratching my head thinking I may have had defective fans because on my Asus motherboard, this fan would not properly run on the chassis fan headers. It was working on the CPU fan headers, and I reached out to Fantex and said, what's going on? Could I have a defective fan? And we actually worked out the problem. By default, my Asus motherboard sets its fan headers to auto control. So auto detect, whether it's DC or PWM. In auto mode, it wasn't properly picking up these fans and wasn't properly controlling the RPM. It was all over the place. It wouldn't stay constant. It was really annoying. So you actually have to go in and manually set your fan headers to PWM mode for these fans to work with Asus motherboards. It may be true with other brands as well. And I've actually requested that Fantex post an FAQ on their website because I'm concerned they're going to get a lot of returns of this fan right out of the gate, get a lot of bad user reviews of people thinking these are defective because they can't be controlled when in auto mode on the motherboard. So go in and make that switch to PWM mode. Another tip I have is that this fan will actually go all the way down to 285 RPM, whether or not you use the performance 2000 RPM mode or the advanced 3000 RPM mode. I was a little concerned that if I chose that ultra high RPM mode that I would have to run at higher RPMs at idle as well, but that's not true. Fantex thought through that and gives you that same very low RPM. 285 is virtually silent. You won't hear it outside your case, so it's really perfect. And it gives you that full spectrum, 285 to 3000, that you can play with using software. Now, there is the hybrid mode that goes down to 0 RPM and goes up to 1200 RPM. That's going to be best for probably case fan use. You could actually get away with it on this fan because it's so good at 1200 RPM. Now, the minimum RPM I tested was 1500 RPM, but it was better than most fans at max. So 1200 RPM may be good enough, but you really probably don't want to use that hybrid mode on a radiator because 0 RPM is never really that great. Even at idle, you want to flush out that heat. You don't want your fan stopping running at 0 on a radiator. So hybrid is going to be for case use, but the 2000 and 3000 RPM modes are fantastic. And I would actually use the 3000 RPM mode even though I don't want to use it at 3000 RPM because then I get that full spectrum. And I could actually set 3000 RPM for some threshold, like maybe 80 or 90 degrees Celsius, almost as an alarm, like, hey, there's something wrong with my system. I better stop what I'm doing because my fans are running at 3000 RPM and I can hear it, right? It's going to be really noticeable. So let me stop, figure out what's going on. Why is my CPU running so hot? It's not going to be something wrong with the fan. I can almost guarantee you that, but you can use it in that way if you have a really good software suite. I use Argus Monitor for my software controls of fans. Now, in terms of observations of the fan sound, I want to say this is the best sounding fan I've ever tested, and I've tested a lot of really good fans. If you listen to the audio samples, you probably noticed there was a difference between this and the Noctua fan, even at the same decibel level, and I do this because this is a big deal, folks. Some people do still ask me, why are you giving me these samples? It's the same decibel level, but it doesn't sound at all alike. And I think Noctua fans typically are a little bit more mechanical. This was just super smooth, and I chalk that up to 3 factors. First of all, the magnetic levitation bearings, they're just super smooth. No noise is going to be coming out of those. The really optimized fan blade profile means you don't get turbulence. So some fans, particularly Corsair ML120 fans, have a lot of turbulence. So even at a specific decibel level, you're going to hear kind of an up and down, kind of a beating that is very noticeable to the human ear that a decibel meter doesn't pick up on. And then third of all, there's the stiffness of the blades and the frame because of the really good materials used here. That means there's no resonance, which is a problem with Arctic fans. So again, Fantex has really done its homework here. This is a perfect fan for radiator use. And overall, look, I've done a lot of fan testing over the past year. I've recommended a lot of fans as I've gone through different tests. The Noctua was previously my favorite for radiators. Game over, Noctua. This is the best fan, and it's actually a little bit cheaper too at 30 bucks. Now, some of you may say, hey, that's really expensive for a fan. I'm more in the market for a $10 or $20 fan. And you know what? There are fans out there for you guys too. Arctic has some good fans, the P12 and P12 ARGB. There's also the Thermaltake Toughfan 12, which is sometimes 20 bucks. Often it's up at 25. And at that point, even though I've recommended it previously, I would not recommend it versus the Phanteks at 30. And then, the Noctua at 33, sorry guys, I'm not going to recommend that anymore. Now that I've tested this on a radiator, the Noctua NF812X25 is no longer my recommendation. So that's pretty much it. Folks who followed this channel know that I've spent a lot of time over the past year on fan reviews. And these have been probably unlike a lot of the other reviews you've seen out there. And it's because they take a lot of time. And I hope you'll acknowledge that. I hope you'll give me a like and subscribe. I hope you'll give me a supportive comment down below because I've really tried to shed light on fan performance. I think for decades, people have been in the dark. They've based their fan purchases on reputation or on the spec sheet. For instance, the airflow or the air pressure numbers that they get on a website. And people still come to me every day and say, why did this fan perform so well in your benchmarks? The airflow numbers on the spec sheet say my fan should be better. Guys, I'm trying to educate you. I'm trying to show you that a spec sheet doesn't matter in a PC environment. I think that's something that Phanteks knew when they designed this fan. Look, like an airflow test chamber is not the same thing as a PC chassis. It's definitely not the same thing as a radiator, right? Airflow doesn't matter at all on a radiator. So I really commend you to think about the way you buy fans. Don't just go based on the reputation, what people say in a forum, or a spec sheet. Go based on the benchmarks. And I and a few others out there are doing these benchmarks. They take a lot of time. Please do acknowledge that when you post your comments. Please be supportive of this channel and others who are doing this hard work. And frankly, more channels are doing this now. And I think to a certain degree, it's because of what I've been doing over the past year. So as always, I'm Ari from the Tech Buyers Guru, and I will catch you next time.